and welcome. Today, we are going to be doing a presentation on Piper Alpha and the events that led to the tragedy the name has become associated with. The information we have gathered will be presented to you today in 4 parts. The first part will be presented by me, Jake. I'll be going through the normal day-to-day running of Piper Alpha. Then Matthew will be speaking about what happened on the night of July 6, 1988, preceded by Marco, who will be talking about the causes of the accident. And Jacinta will complete the presentation by going over the lessons that were learnt from the disaster. Piper Alpha was originally an oil platform that was operated by a company known as Occidental Petroleum Caledonia Limited, also known as OPCAL. The Piper oil field was discovered in early 1973, followed closely by the fabrication of the platform in the Scottish Highlands. The oil field was located in the North Sea, 120 miles northeast of Aberdeen, a northern Scottish coastal city. On the night in question, there were 228 personnel aboard, including staff on a standby support vessel. Piper Alpha was originally designed with safety in mind. The staff quarters were surrounded by a firewall and kept away from potentially dangerous production areas of the platform. However, in the late 1980s, Piper Alpha was converted so that it could also produce gas and condensate, the condensate being mostly propane. This conversion diminished the original safe design of the platform, bringing together sensitive areas. One such critical example was of a condensate pump that was located near the control room. When production started in 1976, Piper Alpha was producing around 250,000 barrels of oil a day. This quickly increased to 300,000 barrels of oil a day, nearly 10% of the total oil output of the North Sea. During 1988, the production of oil had slowed to 120,000 barrels per day. However, gas was now being produced at a rate of 33 million standard cubic feet per day, and jointly, the total was still 10% of North Sea production. From 1976 to 1988, there was a significant drop in the price of oil, from $30 a barrel to $8 a barrel. Because of this drop, OPCAL had scaled back spending on the platform. Piper Alpha had become a hub, processing its own gas and collecting gas from 2 other platforms before sending it on to another separate platform. The platforms were Claymore, which was a distance of 21 miles, Tartan, located 16 miles from Piper, and then the joint gas was piped a distance of 33 miles to MCP01. And from there, it was pumped onshore to St Ferguson Gas Terminal, Aberdeen. That's it for me. I'd like to now hand you over to Matthew, who will be speaking about what happened on the fateful night of July 6, 1988.
First of all, I'd like to thank Jake very much for the introduction. Right now, I want to try to paint a picture of how an ordinary night with 226 personnel on board Piper Alpha turned into a disaster that to this day impacts many lives and industry standards around the world. I'd like to begin talking about the start of night shift, July the 6th. The Northern Sea has a well-earned reputation of being a harsh environment. In August, July the 6th was reported by personnel as being a very calm day in the Northern Sea that evening. At 6 p.m, the scheduled shift handover commenced to begin night shift. 62 personnel were on duty for the night to take control of the full operation of Piper Alpha. At the same time, 164 personnel were winding down and enjoying their free time after day shift completion. Several hours into night shift at 9:45, condensate pump B tripped and could not be restarted off multiple resets. Control room staff were familiar with this event, as it was noted as a regular occurrence, and although this piece of equipment was critical in maintaining power to the platform, it was dealt with in a routine manner. After several attempts at restarting, permission was given to switch to standby pump A. Condensate pump A was started at 9:55 p.m, and almost immediately after, a heavy presence of gas was noted on the platform. Gas alarms on the deck were activated, however, instantly the gas ignited and exploded, destroying the protected firewall in the vicinity. Emergency stop buttons were activated to close off the gas supply, however the explosion already caused significant damage to other sections of the line, creating fires in a rapid fashion. At 8 minutes past 10, the control room had to be abandoned due to the ever-increasing fire after a final mayday call. While some men on the lower levels had managed to already escape, confusion and disorder was experienced for anyone who remained. With the control room abandoned and no backup on the platform, there was no base established to give direction. Fire blocked access to lifeboat stations, so many staff gathered in the accommodation block awaiting orders. Unfortunately for those waiting, no direction was coming. It descended into a situation of each man for himself. Some staff had made their way to the heli deck, however the flame and smoke had driven off all rescue helicopters and vessels. Attempts were made by personnel to manually activate the diesel firefighting system as the automated system had failed. Some staff were fortunate enough to reach the escaped Zodiacs and made their way to the rescue vessel, the Silver Pit. Amidst all the panic, at 10:20 p.m., the first major explosion occurred, and at this stage it is believed between 20 and 30 of the 226 oil workers had escaped. The first assistance for the stricken platform occurs at 10:30 p.m. from the firefighting vessel the Pharos. At 10:50 p.m., a second massive explosion occurred with flames recorded 100 meters in the air, while 187 men were still on board. This drove the Pharos off, as well as other watercraft in the area that were now assisting with the rescue of personnel who had no other chance for survival but to take the 170-foot leap into the northern sea from the heli deck and other sections of the reef. At 11:50 p.m., the accommodation block, as well as the generation and utilities module, sank, while over 80 men remained trapped inside. Full structural collapse was underway. At 45 minutes after midnight, the entire platform was on the ocean floor while the framework remained burning away. Shockingly, in the space of 2 hours, the rig had gone from smooth operation to a tragedy which took 165 lives and created a $3.6 billion insurance loss in today's value. To piece together this catastrophic series of events that caused this disaster, I'd like to hand you over to Marco. Thank you for your time.
Thanks, Matt. These were unbelievably terrible hours. How could it come to this catastrophic accident? In this part of the presentation, I will explain how an extremely unlikely combination of human errors and design issues were responsible for the worst offshore oil disaster of all times. Let's begin with the primary event that initiated this chain of disastrous events. The initial and primary event was the first explosion caused by the escape of high-pressure gas following the starting of condensate pump A. On day shift, the pressure safety valve of this pump was removed for routine maintenance, and the open condensate pipes were temporarily sealed with blind covers. And because the work couldn't be completed during the day shift, these covers remained in place and were hand-tightened only. These diagrams shall explain the maintenance work carried out on condensate pump A. The diagram at the left shows the typical pressure safety valve bolted in location. The picture at the right shows the condensate pipe work without the pressure safety valve. They are both pipes sealed with blind covers, and these blind covers were hand-tightened only. The first instant of human error was the failure to perform an adequate handover to the next shift. The on-duty engineer filled in a permit which stated that pump A was not ready and must not be switched on under any circumstances. At shift changeover, this engineer found the on-duty custodian busy, so he neglected to inform him of the condition of pump A. Instead, he placed the permit in the control center and left. This permit disappeared and was not found. Not aware of the maintenance being carried out, the night shift crew turned on the alternated pump. The blind covers failed to handle the pressure of the gas leading to the first explosion. This explosion destroyed the firewalls. Flying panels of these walls captured the main gas risers, led to several other explosion and fires, which prevented the crew members' evacuation. Inadequate assessment of the safety hazards, deficiency in the permit to work system, as well as lack in training in the use of permits, were the initial causes leading to this disaster. Also, the automatic firefighting system had been deactivated prior to the incident. The Tartan and Claymore platforms continued to supply oil and gas, despite the flames from Piper being visible to them. If staff had shut down the supplies to Piper, the fire and subsequent explosion would have been much less severe and may have been limited to the gas module. In summary, there were a large number of human errors and design issues. Deficiency in the permit-to-work system and lack of communication started an accident which spiraled into a disaster. Thank you for your time. Now I'd like to hand you over to Jacinta and the aftermath.
Thanks for that, Marco. I now want to take you through the aftermath and the lessons learnt from Piper Alpha. Immediately following the catastrophe, the Lord Cullen Public Inquiry set out not only to find the cause of the accident, but to come up with key recommendations to make sure such an accident never occurred again. In fact, they came up with 106. The key one of these was the requirement for safety cases to be immediately submitted by every offshore installation operator in the North Sea. This was legislated in 1992 and took 3 years for the companies to have their safety cases all accepted. In fact, operators had to spend in the range of $1 billion in order to do this, because the safety case document was something that all workers had to participate in, and not only looked at the safety plans and escape routes and emergency procedures, but identified all hazards on the facility during operation and perhaps decommissioning as well, and reduced these hazards as low as reasonably practicable. There were other legislation such as the prevention of fire and explosions and design and construction specific requirements, followed by a step change in safety public campaign launched in 1997, which aimed to reduce all oil and gas safety incidents by 50%. Finally, in 2013, Piper 25th anniversary came around and a conference was called in the Aberdeen, calling all experts and operators to join in, review the Piper Alpha legacy and determine whether more could be done. If you were to specifically look at what are the key lessons learnt from the public inquiry, I think we can group them into 3 key points. One is the requirement for continuous and quality training of all personnel on these offshore installations, from a tradesperson right through to upper management. There also needs to be an enhancement and focus on safety and design, because it is far easier to reduce hazards at the design stage than try and mitigate them later on. And this is the safety and design legislation that has rippled across the world today, and in fact has even affected Darwin, as of 2 years ago when the Northern Territory legislated this as well. The basic requirements of safety and design is for all design engineers to identify possible hazards and mitigate them at the design stage. There also needs to be thorough and independent auditing, because as Marco has alluded to, there was plenty of auditing on Piper Alpha. However, there was very little quality, because the outcomes of those audits was that everything was fine, when indeed it wasn't. Finally, just to wrap up, the actual global impact on the oil and gas industry, not just in the UK, has been a revolutionising of the safety culture, both from cultural and legal aspects. We now see billboards up at companies displaying the number of recordable hours since the last recordable injury. There are safety first mottos in just about every company. There is the requirement for workers to use Take 5s or job safety environmental analysis to identify risks and hazards as a part of every task they're doing, even on a daily basis, and reduce these hazards to as low as reasonably practicable. And I've already talked about safety and design, which affects all design engineers, and the reason why we have all of these cultural and legal revolutions is because of the observation by Brian Appleton, who was one of the technical advisors on the Lord Cullen Inquiry, which was the sum and quality of each individual's contribution to safety will determine whether someone lives or dies. In conclusion, Piper Alpha remains the worst disaster in oil and gas industry. However, it has revolutionised safety culture, but we cannot forget that complacency can still creep in. In fact, Juliet Hackett, at the 2013 Piper 25 Safety Conference alluded to Deepwater Horizon as an unacceptable example of complacency since Piper Alpha. And in fact, I would like to end off in her words, which are, there are no old accidents, only old accidents repeated by new people. We cannot forget this.